Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much. Good day everyone. Welcome back to my channel at Smart Edu TV. Today we shall be looking at mechanics and properties of matter. And the topic we shall be discussing is projectile. What is projectile? A projectile is a body whose two-dimensional motion in space is affected by gravity. A body whose two-dimensional motion in space is affected by gravity is known as projectile. What are you trying to say? Let's look at this. This is my what? X-axis and this is my Y-axis. We are talking about two-dimensional motion in space. It means the motion of that object can be what? Specified either along the x-axis or along the y-axis. We also notice that from this diagram, the motion of such object is parabolic. It takes what? A parabolic shape. And also, in terms of the what? Acceleration, the object starts what? Accelerating towards the y-axis. The object starts accelerating towards the what? Y-axis. What happens to acceleration towards the what? X-axis? Along the x-axis, the acceleration equals 0. Why? There is no acceleration along the x-axis. Please take note of this. Also, the acceleration that occurs along the y-axis, if you look at the direction of that acceleration, this acceleration is going against gravity. Because the acceleration is going against gravity, then we can write it as acceleration along the y-axis can be defined as what? Negative g. Why? Because the acceleration is going against gravity. Since we understand this, let's now look at the components of projectile motion. For us to understand this better, I'm going to discuss this in form of a table showing the what? Components of projectile motion. Components of projectile motion. So the first one, let's say components. Followed by the horizontal axis. That is the x-axis. Followed by the vertical axis, that is the y-axis. So now what we want to do here, we want to look at what happens to the acceleration, what happens to the velocity, and see what happens to the displacement. In terms of what? Acceleration. Along the x-axis, we said that what? There is no acceleration, that is acceleration along the x-axis equals 0. In terms of the vertical component, the y-axis, what happens to acceleration? Acceleration along the y-axis equals negative g. Why? This is simply because the acceleration is going against gravity. In terms of what? Velocity. Let's see what happens in terms of velocity. Along the x-axis, our velocity is given as what? Ux. which is equal to what? U cos theta. Please take note of this. Our velocity along the x-axis is given as what? U cos theta. Why do we use cos? Anytime we are resolving anything along the x-axis, we always use cos. And if we want to resolve anything along the y-axis, we use sine. What are we resolving? I want to resolve u, the velocity. That means for me to resolve u along the x component, it must be what? U cos theta. Along the what? Y-axis, which is along the what? Y component, I'm going to have u along the y-axis equals u sine theta. These are what? Standard from the idea of resolution of forces. So that means for me to resolve anything along the x-axis, I should have what? That thing cos theta. If I want to resolve anything along the y-axis, I should have that thing sine what? Theta. Please let's take note of this. So the next, let's look at what? Displacement. Let's see what happens to the what? Displacement along the x-axis and also along the what? Y-axis. Along the x-axis, my displacement x is the same thing as what? X. And along the y-axis, my displacement y is the same as what? Y. Either I call it displacement or I call it what? Distance. I'm still saying the same thing. So these are what happens to the components of acceleration, velocity, and displacement, both along the x-axis and along the y-axis. This is very important for us to understand the basics of what? Projectile. It is from here we are going to be what? Generating those equations from our normal equations of motion. The equation we use under projectile, it is still the equation we are familiar with. It's still the equations of what? Motion, or we call it Schubert equation. They are still the same thing. So this equation of motion is what we use in solving problem of what? Projectile motion. Let's now see. If you want to write those equations of motion very well, let's see what we are going to have. I'm going to be making reference to this table in terms of the horizontal component and also in terms of the vertical component. So let's see what we have. So our equations of motion, or our Schubert equation, let's see what happens around the what? Horizontal, that is the x-axis, and along the vertical. That is the y-axis. Okay, so for the first one, let's look at the first equation, which is what? V equals u plus at. V equals u plus at. Where v is the what? Final velocity. U is initial velocity. A is acceleration and t is time. Let's see what happened along the what? Horizontal component. Along the horizontal component, don't forget our v along horizontal component along the x-axis becomes what? Vx. To show that the v is along the what? X-axis equal to, let's see what happens to what? To u. U along the what? X-axis. Resolving u along the x-axis becomes what? U cos theta. Don't forget, anytime we are resolving any letter along x-axis, it is that letter cos theta. Also, plus what happens to what? A along the x-axis. Acceleration along the x-axis is 0. Is 0 times t becomes what? 0. That is why the velocity along the what? X-axis becomes only u cos theta. This guy becomes 0. On the other side, let's see what happens to the velocity along the what? Y-axis. The velocity along the y-axis written as what? Vy. This is what defined as our what? U. Resolving u along the y-axis becomes what? U sine theta. Along the y-axis, I use sine. This becomes what? U sine theta. Then plus at. What happens to a along the what? Y-axis? Acceleration along the y-axis becomes what? Negative g. Don't forget. Acceleration along the y-axis becomes what? Negative g. Why? Because it is going against gravity. If that is the case, that means what? My plus a becomes what? Minus g. Then we have what? The t. So minus what? gt. So we have Vy equals what? U sin theta minus gt. For the second equation of motion, we have V squared equals U squared plus 2as. V squared equals U squared plus 2as. Again, let's see what happens to the velocity along the what? X axis or the x component. Our velocity along the x component is still the same as what? U cos theta. Why? Our a along the x axis is always 0. There is no acceleration in projectile motion along the x axis. For the other side, our velocity along the what? Y axis. Let's see what happens to the velocity along the what? Y axis. Our velocity along the what? Y axis is going to be given as U squared sin squared theta, U squared sin squared theta minus, because of this, minus what? 2gy minus what? 2gy minus 2gy. These are velocity along the what? Y axis, which is what? Minus what? 2gy. Okay. Similarly, then this is what? U square. I should have what? Similarly, in terms of what? The displacement s. Let's see what happens to the what? Displacement. From s equal to what? Ut plus half at squared. From s equal to what? Ut plus half at squared. Our displacement along the x axis, also called what? X, will be given as our u becomes what? U cos theta. U cos theta multiplying t, ut, u cos theta t. What happens to a along the what? X axis? Our a is what? 0. That is why the whole of this is 0. I'm left with what? Only u cos theta is the what? T. Let's see what happens to what? To the displacement along the what? Y axis. What happens to the what? Displacement along the what? Y axis, which is the same as what? Ordinary y. My y will be given as, in terms of what? Y axis. Instead of using cos, I'll change to what? Sine. I'm going to have u sin theta into what? T. Ut plus half at. The half becomes what? Because of the a becomes what? Minus what? Minus half gt squared. So these are what? Equations of what? Motion. These are what? Equation of what? Motion. Our u is Vx equals to what? Using of the what? U squared cos square theta. For the u is what? Having square. Then this one too should also what? Have square. So Vx equals to what? U squared cos squared theta. So please, these are the basics that we first need to know before we what? Start solving problems on projectile motion. Thank you.